All right, sir, we are live now.
Hi, everyone. Good evening, good morning to everyone. Thanks for joining session number 7 of the TSDSI deep dive session. My name is Guna. I'm the convener for the session. Let me start my screen sharing here. Can you guys see my screen?
Yes, we can.
Okay, so um, the session, I want to first start by thanking our session sponsor, STL. Thank you, STL, for sponsoring this session. My name is Guna, and the session co-chairs are Rajesh from STL and Ambarish from Sukta. I'm the session convener. I'm with TSDSI, and Nivedita Pathak is the session coordinator. Okay, so taking a quick glance at the agenda. We're going to start with the keynote 1, which is titled Open RAN, bringing flexibility, agility, scalability, and innovation. This will be by our first keynote speaker, Rajesh, who's the CTO of STL Access Solutions, followed by keynote 2, titled Incubating the Open RAN Ecosystem, putting it all together one by one. This will be by Manish Singh, who's the head of wireless ecosystems at Facebook Connectivity. Then we'll have a quick 20-minute Q&A where the audience can put in their questions in the Q&A tab, followed by a panel discussion. We have an amazing panel assembled. And we have Gilad, who's the CEO of ASOX, Hank, who's our industry expert on ORAN, Chris Rice, who's the CEO of STL Access Solution, Inder Gopal, who's the CEO of Iudx, is also a professor at IIC Bangalore, and Brian Tan, who's a director at Facebook Connectivity. And then there'll be followed by a quick Q&A on the panel, and then we can close the session. So a few instructions to the audience. Everyone will be on mute except the session speaker, so you'll be able to ask the questions using the Q&A tab. If we are not able to get to some of your questions, we will send the same to the speakers via email, and we'll get back to you. What else? So the conference will be recorded and will be posted on the TSDSI website within the next few days. And if you wish to view a previous session while the conference is on, please click on the replay button for the session. So that's pretty much it. Okay, so let me start by giving a quick introduction on the keynotes. Our first keynote is going to get into deep dive on Open RAN, so this session is actually there's been a lot of activity at the access on the access network these days. I mean, plenty of activity. The RAN got disaggregated, which is a huge transition point in the industry. Before that, the entire base station is one monolithic unit, and you can't take the baseband from one vendor and connect it to a radio unit from another vendor, for example, right? So disaggregating the RAN is going to solve a lot of these problems. It's going to break it into 3 functional units. And there's also decoupling between the hardware and the software. And Rajesh is going to get into all these exciting details, how to bring flexibility, agility, scalability, and innovation into Open RAN. So a quick introduction on Rajesh. Rajesh is also a co-chair for the session. I've been working with him for the past 5+ weeks. It's been an absolute pleasure. He's a CTO of Access Solutions at STL. At his role, he drives technology transformation in the open networking domain. He leads R&D engineering and product development. He's also the CPO. So he's also responsible for driving new business growth. And it brings about 25 years of experience in the telecommunication industry. and he's worked in companies like Cable Labs, Charter, Clearwire, Sprint, and Nextel. So I'm absolutely looking forward to the session from Rajesh. So can we move to the first keynote session, please?
Sir, kindly stop sharing.
Sure.
Hi, welcome to session 7, Open Technologies for Access Networks. I'm Rajesh Gangadhar, and I'll be speaking to how Open RAN brings flexibility, agility, scalability, and innovation. So I'll speak to where the industry is today, what is the adoption, and the acceptance in the market, some of the benefits that Open RAN brings, the challenges that are facing Open RAN. Anything that is new and nascent is bound to have challenges. The question is, how do we, as an industry, overcome them? And then last but not the least, enabling India as a global leader in telecom. Open RAN perhaps brings an opportunity for India to lead this space, be a leader rather than a fast follower. So the industry as a whole has been shifting towards open networking, and this has primarily been driven by the operator community because of the way the traditional architecture today is, which is monolithic, it is proprietary, it is closed, and it is very hardware-centric. And what Open RAN does is it actually opens up and disaggregates the hardware from the software. It makes it more programmable. And then it also adds another key element, which is open interfaces, which means that you can now mix and match vendor equipment and seamlessly operate a network without having to worry about interoperability issues. And what does it do as a result? It actually lowers the total cost of ownership, both the CapEx and the OpEx, because now you have newer players driving innovation and agility in the ecosystem. And looking at various industry analyst reports, it's clear that the addressable market is fairly robust. We look at upwards of 5 billion, and the CAGR is pretty healthy as well, year over year. So as I said, the whole drive towards openness has been driven by the operator ecosystem, and we see over 300 mobile operators have committed to various Open RAN trials and POCs. There are RFIs and RFPs, and the ORAN Alliance has done a terrific job of defining the specs and the standards. Of course, the activities are still continuing. There's still work to be done, but by far they have actually set the pace and the tone for defining how these open interfaces will allow the myriad of network elements to interoperate rather seamlessly. And the operators are certainly behind those and working very closely with the vendor community and defining that. And these are some exemplar announcements and logos that we see in the market. If you look at where the Open RAN ecosystem is going. This decade, the 20s, is going to be driven by the adoption of Open RAN. And you can see that moving from where we are today, 2021, where there's roughly about 3% adoption, moving towards 2030, you see the market shifting towards an 80-20, where 80% is going to be Open RAN versus 20% traditional. So this transformation is fairly dramatic and at a very, very fast pace. And even geographically, if you look at the chart to the right, the adoption is going to be fairly even across the different geographies, some ahead of the others, but certainly the transformation is here to stay. So what is openness and what is disaggregation? What is virtualization? Well, I mean, it really means separation of the control and user plane. It means the disaggregation between software and hardware platforms, the interdependence between the two being taken away. And it really leads to a sort of an innovation and agility that was perhaps not as robust in the previous generations. And you can see that the open interfaces and the open source communities are driving a lot of this innovation. And what ORAN is defining is some the boundaries and the specification definitions that will bring all of this together. And so what it does is it actually allows the operators to move away from a vendor lock-in. They will have much more opportunity to choose from and a broader breadth of vendor ecosystem. Networks will be allowed to be more flexible and scalable, and also allow for faster time to market because of the innovation pace that is going to happen. More and more players are now going to be able to play on an even playing field. So what does the separation or the disaggregation bring to the table? The 3GPP has defined various functional splits. Previously, in the traditional architecture, you had several of these protocol layers all aggregated in a single box. It was called the baseband unit. Traditionally, the radio unit was also integrated. There has been a disaggregation between the radio unit and the BBU during the 4G evolution. With 5G, you now have the opportunity to split it even further, and the split will be defined by the different deployment archetype. And why that is so critical is 5G is not just about the 5GNR standard. It is all about bringing an ecosystem of different services, application, and customer segments that were previously not as well supported by the wireless network. So it is an amalgamation of use cases, applications, as well as the technological advances and the flexibility that it brings. So the freedom that the disaggregation and separation of software and hardware brings to the operator is that they are now able to flexibly deploy different architectures to support different use cases. And this is very critical as we evolve the networks towards 5G and beyond. So this chart basically shows you the flexibility that I was talking about. It actually brings the operators now have the ability to define and plan the network to address various customer segments, whether it is enterprise, whether it's dense urban, suburban, rural applications, whether it's different use cases, hospitality, private networks, industrial automotive plants, etc. They all have different SLAs and requirements for bandwidth, latency, and applications. And you also are driven by the limitations around the bandwidth or the front haul and back haul that is available to an operator to drive this network build. And so this flexibility was previously not available. And what this functional split and openness brings is the ability for the operators to mix and match the network elements, deploy them in various fashions, and still be able to run a fairly seamless network, an agile network to serve various customer segments. So as I said, what's the reason for the functional splits, and what is driving some of that? Well, for one, what is known as the CUPS architecture, the control and user plane separation is very critical because they scale differently. And with 5G, where you have different logical and physical resource requirements, you need the capability to do network slicing to support multitudes of applications and use cases. And as you see here in the graph, this single, rather homogeneous network that we show here is now able to support multitudes of applications and services concurrently. And that's very critical. And that's only because you're able to now separate out the control and user planes and the forwarding planes. So, and the fast scheduling and the intelligence that is built into the network is what will drive the ability for the operators to run various use cases and applications concurrently, defining various SLAs, being able to support various bandwidth and latencies. And so while the standards define EMBB, URLLC, etc., practically, how do you apply that into the network? How do you deploy the networks to support? That becomes the most fundamental, critical application of those use cases in the standards. And so Open RAN allows the operators to bring various network elements seamlessly together from various vendors. They seamlessly interoperate and lower the cost of ownership, increase the agility and the innovation pace, and so the operator is actually in control of the overall network that they are deploying for various customer segments. And that's a fundamental change. It's a shift, a paradigm shift in the way the networks have evolved. And one other critical element is the convergence of hyperscalers and telecom networks. And what I mean by that is you're actually bringing data centers to the edge. And this architecture, this flexibility is what drives that edge cloud platform, because now you are essentially hosting the telecom infrastructure on IT infrastructure. And that convergence is happening today as we speak. Amazon, Google Cloud, Azure are all bringing data centers to the edge at various shapes and sizes. And then the networks are sort of converging towards the data center architecture. So that's the fundamental principle of disaggregation, openness, and virtualization. And as I said, a lot rides on the intelligence that is built in the infrastructure. And that intelligence comes from what is being defined as a Lan Intelligent Controller. There are two types of controller platforms, the near RT-RIC and the non-RT-RIC. These are an evolved platform from the SON functions that we all are familiar with. There have been limitations on the SON, whereas the RIC brings near real-time application. You're talking about seconds, milliseconds, as opposed to minutes and hours of action that takes. And this leverages an AI ML engine where a lot of these decisions are made autonomously. And so this platform architecture that brings the RAN OANM platform, the RAN domain orchestrator, the RIC platforms, all of these converge to give a homogeneous feel to the whole cloud network automation platform. And what we are fundamentally also seeing is that there is a move towards third-party XApp and RApp applications. These applications will define the different use cases that the operators must support. They can be all the way from mobility management, load balancing, power management, operational efficiency, fault management. All of these SON functions that the legacy networks have will now reside in the RIC architecture. And the third-party applications, it actually essentially opens it up almost like an Android or an iOS platform where you have third-party party developers that will bring applications natively as well as externally to bring, but cohabitate and work together in a single platform. So that's the architecture that is going to be enabled and will also enable the ecosystem to evolve, to bring intelligence to the edge. So a convergence of the network architecture into the cloud infrastructure, the onboarding of intelligence platform onto that cloud native platform is essentially bringing this whole architecture to a very different space. It's a paradigm shift in the way telecom infrastructure has been around for several decades now. So as I mentioned earlier, I mean, anything that is new and evolving will also have challenges. And how do we surmount that? How do we collectively come together? That is the key to the success of Open RAN. And so fundamentally, if you look at where Open RAN is, it is still maturing. We are in development phases, various development phases. The good thing is there's several proof of concept trials that are occurring right now, and that only matures the system even further. What is really impressive is the collective mandate from both the operator community and the vendor community to see this become successful eventually. So there's a lot of collaboration, co-creation, cooperation that is happening between the operators, the vendor, different vendors that are supporting Open RAN, to bring all of this together and allow for seamless operation. System integration becomes critical because you're now bringing different disparate network elements from various vendors. Even though the system interfaces are defined as open standard, there's still configuration parameters that have to be set. You have to figure out the bugs and anomalies, figure out where those bugs and anomalies are occurring, work at collaborative environment, and ensure that the networks perform seamlessly. And this is very fundamental and critical to the success of Open RAN. So system integration of various in a multi-vendor environment is a key to success of Open RAN. Security concerns, yes, anything that has the phrase open means, it has a direct connotation to perhaps a security concern, but then openness doesn't mean that the systems are not defined with very specific, clear guidelines and specifications. So while the concerns exist, there is also a lot of work that is being done, specifically in ORAN Alliance, the ORAN forums, to define what those security parameters are going to be, to enable these interfaces to be secure and have foolproof ways of integrating and interfacing between network elements. So these are some of the challenges. Well, how do we overcome them? And as I said, collaboration, cooperation is fundamental. And what we've seen is operators are driving that. And this is, again, putting the control back with the operators to define what the specs are, what the efficiencies and the operational efficiencies that they require. All of these are being very clearly enunciated, and vendors such as us are building products around these specifications. So it's a collaborative effort which is driving this faster adoption. And as you can see, the ecosystem in just a span of 2 years, even through the pandemic, has evolved tremendously. Interoperability testing, as I said, system integration and interoperability are two critical elements. The interoperability, again, having labs that allow for these various network elements or vendors to work together and provide a seamless solution, that becomes very critical. And as I said, security is another key element that is being very clearly defined in the standards. How can the government of India support, for example? How does India lead this ecosystem? It's a fantastic opportunity for us to lead. And while the government has done a lot of good work, and in fact, the speed at which it is moving is incredible, there's a lot more that can be done to actually stand up this ecosystem, to boost the startup ecosystem in India, to create IP, to validate some of these technological advances seamlessly, to support that the infrastructure and testing capability in India. While there's been a lot of announcements by both the vendor community as well as operators, there's a lot more that can be done to improve, to speed up the adaptability and development. So maybe some of the focus areas could be around where we see the gaps today are around the specifications for certification. Again, we are moving from hardware-centric to software-centric products. How do we certify the products? How do we define the specifications around the clarity that is available? Where do we test it, validate it? Can the government help with defining or creating these labs where small and large vendors equally that are in India can come in and test their equipment and get them validated. These are highly capex intensive products and solutions. In order for us to innovate fast, to bring these products and lead the industry, a lot can be done around testing, validation, and allowing for interoperability of these products. Creating the ecosystem for upskilling of the workforce. That is another key element here. We're finding that there's just not enough people who understand this, and the fact that we're moving at a breakneck speed doesn't permit us to provide as much training, and that's a big gap. The skill gap is huge in India, and if anything can be done, that's the area of focus that the government can help with in subsidizing education, training, and upskilling of the workforce. And so there's a lot that India can do. There's a lot that India can gain from, but some fundamental approaches have to be taken in defining what that needs to be to create a really healthy pool of IP, create unicorns in India, allowing for the industry to move at a much faster pace and scale very quickly for the global market. And that's something that both from a investment perspective as well as infrastructure, standing up the infrastructure perspective, the government could do a lot. So I'll end here. Thank you for the opportunity, and I hope this has been useful. And I look forward to the questions in the Q&A segment. Thank you.
Thank you, Rajesh, for the incredible session. Really appreciate it. So let me share my screen once more here. So now we're going to move into the second keynote session of the day. And we have Manish from Facebook Connectivity. So before I introduce Manish, so let me quickly introduce what he's going to talk about. So Rajesh got into a lot of details about what the RAN is all about, disaggregating the RAN, the challenges associated with it, and all that. So, it is incredible what this actual transition has done to the industry. Now you got one monolithic unit and you've broken that into multiple smaller functional units. And of course, when you do that, you got all these different vendors who are also going to supply equipment in all these different categories. And you have to make sure that the equipments interoperate with each other. And, there's a whole bunch of ecosystem that needs to be developed. And that is a big task. And Facebook has been doing an incredible job there. And to tell us all about it, we have Manish. And Manish is the second keynote speaker. He's going to join us from Silicon Valley here. He's a well-respected industry leader with 20 years of experience in wireless networks. He's very active with Open RAN and Open Core projects, Open Core network project groups in TIP. I'm sure everybody would have heard about TIP. And so for 3 years, he served on the board of Small Cell Forum. Before joining Facebook, he was at Tech Mahindra. And prior to that, he was Radisys CTO. And prior to Radisys, he was a VP of Product Management and Continuous Computing, and where he led their growth in small cells and DPI. So during the course of his career, he's held several positions at Intel, Trillium, CDOT, and he's routinely featured as a keynote speaker in different industry events. So we are extremely glad to have him today. So let's get to the second keynote session of the day.
Hello, I'm Manish Singh from Facebook Connectivity, and it's truly a pleasure to be here to share with you how we are incubating the Open RAN ecosystem. Let's start with why. If we look at the RAN equipment sourcing today, Most of the operators source the equipment from a single vendor, and the equipment itself is very tightly integrated, hardware, software tightly integrated with no open interfaces. And the end result of all of that is there's been a very strong lock-in on the radio access network, and the rate of innovation has really slowed down. Open RAN is a movement that is working to disaggregate the RAN and disaggregate the RAN on two key vectors. First and foremost, hardware-software disaggregation. And secondly, functional disaggregation across a radio unit, distributed, as well as centralized unit, but most importantly, with open interfaces. And the end objective is to really build a diversified, sustainable supply chain, accelerating the innovation of the radio access network itself, and then improving the network economics. Let's take a quick look at what are some of the key functions of an open RAN. Starting with radio unit and RU, this is where a lot of the lower RF functions as well as the lower PHY functions are combined. And this is typically sitting on top of the tower. And then you have a DU, distributed unit. This is where most of the RAN functions, the layer 2 functions in particular, and some layer 3, but a lot of layer 2 and the upper PHY functions are consolidated. And the front haul interface between an RU and a DU is an open interface, which is being specified within ORAN Alliance. And then you have a centralized unit, which centralizes further the function of the RAN, in particular the layer 3 functions for the radio resource control, as well as higher layers of data plane protocol on PDCP, and those functions are getting consolidated in the CU. And so you have your basic function between an RU, DU, and CU with open interfaces between them. But Open RAN takes it even further in terms of disaggregation and introduces new functions, a logical function like RIC, a Lan Intelligent Controller. And RIC really enables the ability to start consolidating the control functions, be the brains of a radio access network, and on top of it, enables a framework where you can start to apply AI and machine learning technologies to really improve the performance, the throughput, KPIs, energy efficiency, etc., of the radio access network. And on top of these RIC platforms or this controller would be a variety of apps. And a good analogy to think about is how the phone world changed with the smartphones and a variety of apps. And so an operator now has the option to bring in the right app for the right use case or the right environment that they want to solve for, and it gives them that choice. Now, these RIC platforms also come in different flavors. You have near real-time RIC, non-real-time RIC, and that really is more of a function of the control loop in terms of time granularity, is how quick the decisions have to be closed. And if it is more sub-second, then you are talking about near real-time RIC, or if you are talking of decisions that have to be close of the order of a second or more, then you're talking more about non-real-time RIC. But the meta point being, these controllers then give you the ability to start driving more control, granular control of the radio access network. So to really support all of this disaggregation and further innovation through the RIC and XApps and more, the Telecom Infra Project, TIP, which is an industry consortia and supports a variety of project groups which are looking at different problem domains. Within TIP, one of the key project groups is Open RAN, and the Open RAN project group is focusing on advancing different work streams of RAN disaggregation. And within TIP, within Telecom Infra Project, the goal is to, again, develop the ecosystem, work with the mobile network operators across the globe, identify their key requirements, consolidate the requirements, give a good, strong demand signal to the vendor community, the developer community, and then based on those aligned requirements, work with the vendor ecosystem to come up with different products and solutions that meet those requirements. And so the Open RAN project group itself it consists of a number of subgroups, each of it as a work stream. And there is a RU subgroup, which is working with operators on developing the radio unit requirements. Similarly, there's a DU and CU subgroup, which is looking at the consolidated requirements of a distributed unit and a centralized unit. Then there's a RIA, a RAN Intelligence and Automation subgroup, working with operators on different use cases for RIC and XAPs, and how AI and machine learning can be applied onto the RAN. And a number of those use cases have already been published within TIP. Then there is a subgroup ROMA, which is more around RAN orchestration management and lifecycle management and automation. And ROMA in particular is really looking at all the orchestration aspects as well as CI/CD and how you apply a CI/CD lifecycle management onto the radio access networks. And then there are two segment subgroups. So while each of the component subgroup is working with the operators to identify the requirements, the component subgroups are looking at how do you bring all these different components and then create complete blueprints for outdoor solutions as well as for indoor solutions. So those are some of the key groups within the Telecom Infra project under the Open RAN project group. And to just give you a quick idea of how within TIP, we're working with different operators and building the demand signal and sharing the consolidated requirements. Recently, TIP had shared the requirements from the Open RAN MOU group operators, the 5 operators from Europe, including Deutsche Telekom, Orange, Telefonica, TIM from Italy, as well as Vodafone. And these operators shared their Open RAN MOU group requirements with TIP. And these requirements, if you really look at, they span all the different parts of these RU. There are DU/CU requirements, there are cloud infra requirements, there are front haul requirements, plus there are requirements then on different RAN features. And then in addition to that, there are requirements for RIC as well as different XAP use cases. And then there are management and automation small requirements as well. And so TIP is now working to take those requirements and translate those requirements into solutions, but doing that through an ecosystem and bringing that ecosystem together of RU, DU, CU, hardware, software providers, as well as RIC and XAP providers, bringing all of these together and realizing full solutions. And this is being done through 3 step release process. We're right now in the definition of release 2, which the requirements for release 2 now are being defined, and in the years ahead, we'll be getting those requirements finalized and then take them into trials and deployments in the 2023 timeline. And then there will be a release 3, which will be focusing much more even on the RIC, XAPs, as well as some of the automation use cases and the work of that as it starts in 22, but will continue to build towards 2025 in terms of trials and deployments. So that's an example how the Open RAN MOU group operators came together, shared those requirements, and how TIP is now working with the ecosystem to take these. And it's not just in the defined state. From there on, we'll be getting into the build, bring different ecosystem vendors together, leverage TIP community labs to drive test and validation, and then take them into release, and then finally into deployment. And deployment, talk about that. That's a key focus for TIP to drive not only work with the ecosystem, but really then to get this tech out into the field and get it deployed. And so just to share with you an example of that, there was one of the trials that was done with Vodafone in Turkey, and this was a trial that spanned, this was one of the very first trials of Open RAN. This was done in 2019, and this was, around 25 macro sites covering 2G, 3G, and 4G. This was rather one of the very first Open RAN trials covering around 70K population area, and Vodafone within Telecom Infra Projects, shared the KPIs, and those are all published, they're available. But the meta point being the tech's maturing, the KPIs here compared to the incumbents were really, really strong after the optimization phase. And what that led was, for example, Vodafone to really invite the Open RAN ecosystem to participate in, back then, what was one of the biggest RAN tenders covering different opcos throughout Europe. So that's an example of trials and then sharing with the community different results. And then, just to share a little bit more, while I shared the Vodafone Turkey, there are multiple other trials that TIP is supporting with its ecosystem members, and these span across all different continents, from trials going on in North America and Latin America and Africa, parts of Europe, Asia, and more. So this is again part of our journey to really support the deploy phase, but drive more and more adoption of the Open RAN technology. And so while there has been good progress through that journey, we also realized that there are certain barriers that really need to be solved for. And this really led Facebook Connectivity to set up a program called EvenStar. And the goal of EvenStar is to accelerate Open RAN adoption through product innovation and partnerships. And those are our two key principles to build that ecosystem to drive that. The barriers that we found as we were building the larger Open RAN ecosystem, first and foremost was the availability of the radio units itself for the macros, and there was very limited supply. And then the cost competitiveness, that's another challenge that we saw as we were building that ecosystem, that there are challenges around that. And then on the technology side in particular, complexities around massive MIMO. Then, in addition to that, interoperability. So as you disaggregate the functions, you need to bring them back together and integrate them and give a full RAN solution. And that brings in some of the interoperability challenges. And then last but not least, the meta goal being to lower the TCO. So these are some of the barriers of adoption. And EvenStar as a program has been working on really tackling some of these challenges. There are 4 key tracks at a high level. First one is on the radio and the baseband unit. And this is really, again, working with ecosystem partners. STL spoke before us. They're one of the EvenStar partners working on the RU. And the goal is, again, to bring together this ecosystem under EvenStar with RU and DU supply chains, and there are reference designs that are available. And these early reference designs, the goal is to again start to enable the deployments and start to build supply chain. That's really, really important. And that's the starting point. In addition to that, EvenStar program in collaboration with TIP and with other operators working on interoperability. And this is really to, again, drive that openness on the interfaces and be able to mix and match, so that interoperability and certification is a key part. And this is, again, the value here is, again, to accelerate the adoption. And then as we move further, massive MIMO, that is key to really get Open RAN adoption moving at scale. And so under EvenStar, one of the other key work streams is to work with the tier 2 OEMs on massive MIMO work streams, and already a couple of solutions have already being brought together. And then also test and measurement, that's another key pillar for the massive MIMO side of things for EvenStar. And then last but not least, the silicon pillar. And this is very important. This is important to really drive the total cost of ownership and really lower, some of the costs, because innovation and solving for cost starts with silicon. And so EvenStar program on its silicon track has been working on developing, some of the silicon solutions, both for the RU as well as on the DU side of silicon solutions. Here's a quick roadmap of EvenStar. And if you really look at the RU track, there's already an early reference design available for band 3. But as we move forward, the roadmap is, again, work with different partners to bring a robust portfolio of single band, dual band solutions for RUs. And then further down in the roadmap, the goal is to, again, drive better TCO, better cost optimization through silicon, through SOC-based solutions. Similarly, on the DU track, there's already a reference design available today on the 4G, 5G high capacity DU. And then going forward, the Even Start program, working with some of the SoC partners, will be bringing more cost optimized solutions for DU in the years ahead. And then on the massive MIMO track, this is something that is already currently underway, and we expect to have first tech trial in next year. This would be FPGA based, and then as we continue to advance our work on these SoC, the SOC tracks, we expect to be able to leverage those and bring more optimized solutions, 32T, 32R, 64TR solutions in 2023 and beyond. And then, as I said, the last track, which is on the merchant silicon side, working with different silicon partners. Some of them are announced, Marvell, MaxLinear, and others. We're still working with them. And so stay tuned as those programs mature. We'll be announcing more in terms of different SoC options available for Open RAN. I won't spend too much time on it, but the meta point here is, as we continue to work with the partners and with the ecosystem, one of the key things we're also trying to bring to them is, again, drive adoption and thereby, get them to achieve a sizable amount of market share, a TAM of the RAN. And our goal is that by 2025, work with the operators and with the partners to push for 10% plus of the TAM for Open RAN itself. The couple of quick things for the partners, and in particular, if anyone is looking about thinking of, if you want to start RU, DU, CU, what's the program looking like? There are three key pillars on the RU and the DU side. The first pillar being on the developments. There's an open architecture under Even Star, and working with the partners, providing engineering support, and then supporting some of the development work and productization work. This also then the second pillar there being the sourcing of components for better BOM optimization, and then also for demand aggregation, working with different operators. And the third key pillar, which is why I'm here also, is to again evangelize, get the word out there, drive more commercialization, more marketing, more adoption, more awareness of these solutions coming up with different partners, and getting the operators to really understand that the choice for their RAN networks is really growing and building. Similarly, on the massive MIMO side, the three key pillars for the partner programs, first and foremost, is again building that modular architecture for the massive MIMO designs and working with different partners on 34T, 34R, as well as 64TR solutions. And then also the silicon thread really ties in on the massive MIMO side as well. Test and measurement, that's going to be a key pillar for the massive MIMO because we do want to drive that interoperability, reduce the integration barriers, and make sure that solutions that come out are really enabling those open interfaces that are getting specified in ORAN Alliance. And then last but not the least, again, part of it, especially also around IP development, especially for on the massive MIMO side, including algorithm development, simulation, and more that we are supporting and will continue to. This is my last slide, just to close all of this. Really excited to share with you the Even Star ecosystem as well. A number of operator partners, Vodafone, Airtel, Axiata, they're already working with us. There are a number of hardware partners, and that's growing. I talked about STL, and there are more who are continuing to work with the Even Star program. And then similarly, there's a growing software ecosystem as well, and bringing all of these together to drive and accelerate the adoption of Open RAN. And on that note, I do want to thank all of you for giving me the opportunity here to share what we are doing and share with you how we are accelerating the adoption of Open RAN. Thank you very much and have a wonderful rest of your day. Bye.
Thank you, Manish. That was wonderful. It is truly fascinating what's going on with Even Star and how big the ecosystem is and how incredibly challenging the whole task is, right? So can we get both Manish and Rajesh? Hey, Rajesh, Manish, thank you. It was excellent keynotes. So at this time, I would, it's open for questions. The audience, if you guys have any questions, feel free to use the Q&A tab on the right. You see the small Q&A tab. You can put in your questions. You can't ask the question, but you can just type in your questions, right? So, so we have 20 minutes of these guys, so you can ask any questions you want. So as we start getting in the questions, Rajesh, I had a quick question for you, right? So, see, one of the things that you mentioned with the Open RAN is the need for an SI to integrate various network elements and how challenging that whole task is to get various people, interoperate, and all that stuff, right? And one might actually argue that hey, this is too difficult, right? Maybe I should just stick with my traditional architecture, right? I mean, what do you think about that?
Yeah, thanks, Gunnar. So good question. Maybe the way I'll answer that is with any technology transformation, there is always a thought process. There's a mindset shift that needs to go with it as well. Yes, when you have a disparate set of network elements coming from various vendor ecosystem partners, someone has to put it all together and it has to work seamlessly. And in my talk, I did reference that part where interoperability becomes critical. Working as a consortium becomes critical. System integration in this case is again a phase where a lot of these new network elements that are being defined, the interfaces that are being defined, will have to be tested and validated. But very soon there will come a time where these products from various entities will be more or less plug and play. And I know it's very simplistic to say that. It's easier said than done. But if the specifications are defined correctly, if the players, the ecosystem partners work together, Manish referenced TIP, what TIP is doing, bringing that whole ecosystem to work together, then it's only a matter of time before we start to see these network elements begin to sort of interplay almost seamlessly. So system integration, while it seems like a rather huge uphill task at the beginning, will then ease out to more around automation as more and more of these start to work.
Rajesh, it looks like you're having some
also
bandwidth issues there.
The team will ensure that a lot of these networks, and that's kind of where we see the ecosystem evolving.
So Rajesh, one quick thank you. I think that was a well articulated answer. One quick suggestion. I think can you switch to low definition? There might be some bandwidth issues on your side. So.
Sure.
Can you hear us, Rajesh?
Yeah, I did.
Yeah. Okay, great. Thanks. Yeah. So appreciate the
Yeah,
answer.
I can.
Yeah. Thank you. So one quick tip for the audience: I see a lot of questions coming up. That's great. When you put the question, it'll be good if you can also specify which speaker you want to address the question to, right? So let me go one by one. I think the first question there is how AI ML play the role in ORAN. I think would that be a question, Manish? You want to run with that?
Sure, Gunnar, I can take that. So, as I talked about with Open RAN and with opening up of the interfaces, this now starts to create an opportunity to really apply the AI and machine learning paradigm onto the RAN and apply that on multiple problems around RAN optimization, problems around massive MIMO, to give you examples on beamforming, multi-user pairing, and more. And then really even take it further
to really start applying these paradigms for energy optimization, which in the case of RAN is going to become more and more important as we densify the networks, and we also as we start to bring more and more MIMO and massive MIMO solutions onto the RAN network. So this does start to open that up to give everyone an understanding of how we are approaching this. There is a work stream called RIA. I mentioned about that earlier within Telecom Infra project, where we are working with different operators to identify the use cases and really detailing down out the requirements of these use cases. We are then also trying to work with them to identify what are the data sets that they would be needing to, to enable these use cases, and then work with the, RIC providers, the platform providers, as well as the developer community to build those solutions. To give you an example of that, was one of the, or maybe I can give two quick examples. One, the work that we, again, it's in the public domain that Vodafone announced as one of their first solutions that they trialed with some of the ecosystem partners on the massive MIMO side of things, including with some of the ecosystem players like Cohere and Networks and others. And they've shared, what kind of performance gains they could start to realize there. The second one is an ongoing trial with Deutsche Telekom, in which case collaborated with ONF, the Open Networking Foundation, on their SD-RAN RIC project. Because for us, all things start with enabling the ecosystem, including some of the open source communities that are looking at these problems. And the goal again is, as we open up these interfaces, which, to be clear, there still remains a lot of work, and that work's happening in O-RAN Alliance, and they still need to get those E2 interfaces, etc., get more crisply defined for the use cases. But we got to start, and where we are starting now is actually picking a set of use cases, proving what's possible in terms of optimization, in terms of performance gains, and then, of course, liaising with O-RAN Alliance to see how these get translated into more open interfaces, especially on the E2 side of things, and then get realized. But it's really a paradigm of with the RIC and the X apps that really starts to enable that.
Thank you, Manish. Appreciate it. So looks like we have quite a few questions have come up. So we need to, let's see whether we could keep addressing them. Let's see. There's a question about security concerns on ORAN. There's a particular specific question on ORAN in Central Europe, as per my trials map slide from Facebook. Any specific reasons? Is there something that you want to talk to?
Yeah, I mean, I can take this. I can take both. Just on the security concerns, I think this is an area that gets talked a lot about Open RAN, and to an extent, I think as we open up the interfaces, it actually creates an opportunity to make them more secure. So I think if you look at it from a security paradigm, it does actually create a paradigm where as the RAN gets disaggregated and the interfaces become more open, that it will create newer opportunities for security solutions to be applied and make the RAN more secure. Different operators are taking different approaches because, again, also as they start to realize their infrastructure, they're brownfield operators who have existing network assets and they need to transition. So they will have different approaches versus some of the greenfield operators who are coming up who are taking a different approach. I'll just point the audience to one of the papers that, for example, Dish Networks put out on their approach to zero trust model and how they are actually applying security for the Open RAN that they are deploying. So that's one of the a good source available in the public domain to take a look at for those who are interested in the audience. The second part of your question on the Central Europe, that's a good observation. Keep looking at this map. TIP publishes this updated map every 6 months. We're trying to keep this information refreshed every 6 months as part of the TIP blogs. And yes, you will see more greens coming up on the Central Europe side of things. I mean, a year back, you would have seen much lesser green. So yes, it's a journey. As the tech starts to evolve, the ecosystem starts to come together, and the operators build more confidence. Those trials are growing, and as I shared, one of the very early start of trials on the Open RAN side, rather two. One was in IPT Telefonica in Peru, and the second one was Vodafone in Turkey, and those were some of the very, very early trials. So yes, those things will light up, and we know there are multiple operator partners who are working in SIP and actually starting some of those trial activities. So please stay.
Thank you. Thank you, Manish. Looks like we got Rajesh back. Rajesh, can you unmute your line, please?
Yeah, I'm here. Yeah, I'm here.
Yeah, so I have a follow-up question to Manish, but before I go back to Manish, you still have to unmute your line, I think, Rajesh.
No, I'm unmuted.
Okay, we can hear you. So there is a specific question for you. Let me read it out. RAN specify the details of the interface between various components. Is there anything done similarly in hardware for reference hardware or open hardware? This open hardware can help in even testing the ORAN interfaces on the platform.
Sure.
Hopefully you understood the question.
Yeah, I think the question was around maybe defining the parameters for the hardware itself to make it more generic, really truly off-the-shelf COTS-based hardware. So such an effort is already in motion in the ORAN forum. In fact, Working Group 7 is defining those specs, and I know that several of the hardware providers such as Dell, HP, Supermicro, etc., are actively participating in that working group. So yes, indeed, that will eventually pan out as being a more generic hardware platform that supports, say, an x86, FlexRAN-based solution versus perhaps an ARM-based processor solution as well. So that would be the end goal for that working group.
Oh, thank you, Rajesh. So let's keep going through some of the questions here. Let's see. Audience, keep putting the questions. If there are some questions we're not able to get to, we will definitely respond to you by email. Manish, one quick follow-up question from your first answer, right? So how would someone, if I'm a new OEM, if I'm a new OEM, maybe from India, right? So how would I be part of your ecosystem? What do I have to do? How can a vendor participate in that?
Yes, I think these are open ecosystems. The goal is, again, to grow the ecosystem and get different kind of ecosystem members to participate. And it depends. I mean, I think Rajesh touched on SI part. So it could be RU, if you're an RU provider, DU provider. And within that also, if it depends on what you're doing, if you're developing, hardware, COTS hardware for the DU, are you doing layer 2, layer 3 software solutions? Are you a systems integrator? Any one of these ecosystem members have the opportunity to participate in that. Just for extreme clarity, even Star and Open and TIP, Telecom Infra Project Open RAN Project Group, they are two distinct programs. TIP is an industry consortium, independent consortium that Facebook did help create, but it has its own governing board and its own foundation. Even Star is a program that FBC has created, the Facebook Connectivity has created with a set of operators. But irrespective of that, both programs are open and working with different ecosystem members to come together and realize different solutions. So as I shared, the Open RAN MOU group operators, the 5 European operators, they've shared the requirements. And TIP is very actively working on translating these requirements into solutions through an ecosystem. And one thing I will always say, I mean, we're working also very closely with ORAN Alliance and from the Facebook connectivity side to support the specification work and the open interface work. There's also collaboration going on some of the interoperability and plugfest side of things that's going on. So that's important. But I always say this: open interfaces and requirements are necessary, but they don't necessarily, they are on their own, are not going to translate into an open ecosystem. And translating these requirements into solutions through an open ecosystem is what the focus of Telecom Infra project is. And that's something we are constantly working for. And so, yeah, if you're out there, it's a big tent. There's room for everyone. We're working with SIs on interoperability testing and actually taking these solutions into operator networks, tie them further up in their northbound systems on operations and support. So there's those work streams. That if you are a tester and validation vendor, there are opportunities to work in the TIP community labs or operator labs to bring that test and validation capabilities. And as I shared, SCL is one of the key partners on the Even Start program, for example, and working with SCL as an example on the Even Start RU side of things. And so these are all examples of how the program remains open, works with different players. And if anyone is interested, then yes, please, very welcome. Brian Chan is here. He'll be speaking later. He's based out of Singapore. He supports a lot of the Asia, Pacific, and India ecosystem development. So I would definitely suggest please get in touch with Brian. And
thank you, Manish. So that was wonderful. I just got a reminder that we're running out of time, but before we go, we have an incredible panel assembled, right? But Manish, Rajesh, a quick few words, right? I mean, you've been in India for a while. I mean, I think we would love to hear from you, like what's going on with respect to driving open networking activities with respect to the Indian ecosystem, and what are you guys doing there, right? Quickly, right?
Sure.
We can move to the panel.
Sure, yeah. So I think Manish touched upon one aspect of it, which is we're definitely focused on providing a robust radio ecosystem, and that's one of the partnerships we have with the EvenStar program. We are developing radio. The other is we're also working very closely with the startup ecosystem in India, and I'm really pleased and proud to say that we've actually worked with, we are still working with a couple of partners, EVDN and Sankhya Labs. This is one of our main goals, is to stand up this robust ecosystem in India so that we actually can scale in terms of providing open networking solutions. Besides the radio piece, we're also developing the Lan Intelligent Controller that Manish was referring to. It's a critical component for the success of the Open RAN architecture. And not just on the wireless side, but also on the fixed access side, we're doing a complete virtualized stack to drive the last mile access using white box, OLT, and ONUs, and call it a programmable FTTX. So we're also trying to disrupt that ecosystem there. But having said that, I think the one maybe thought I'd like to leave is, what the US has done or is doing right now, starting all the way from the FCC. There is, almost a mandate to enable open ecosystem in the country. If you look at the platforms for advanced wireless research or NIST, they're all standing up test beds to bring all of these network elements to enable test beds to drive this interoperability and to stand up that ecosystem within the country. So I think we need something similar here. There's a lot of potential, but to tap that, you will definitely need to, there's a private-public partnership that can drive that ecosystem forward.
Thank you. Thank you, Rajesh. I think we have a lot of questions. I don't think we can get to everything. Sanjay, Nishant, we will definitely try to circle back to you when we get the time. Apologies if we're running out of time here, but we need to move on. We need to go to the panel. So again, a big thank you to two of our keynote speakers, Manish joining us from Silicon Valley. Rajesh, thank you for your time. I know that you guys are all very busy. I appreciate you taking the time to share your thoughts here. So let's move to the next. Let's continue with our session. Now we're going to move to the panel. I'm going to start sharing my screen again. So we have an incredible panel, guys. So before I'm going to let let Ambarish talk about our panel. So Ambarish is our co-chair, and he's also another person I enjoyed working with and putting this whole thing together in the last 6 weeks. It's me, Ambarish, Rajesh, and Nivedita. We spent a lot of time in putting this whole thing together. So Ambarish is a director of engineering at Sukta. He has 15 years of experience in telecom and cellular wireless industry. His expertise and experience are in 3GPP specs, developing the products, both with network infrastructure and test segments. And Sukta is responsible for 4G and IoT products. He's managed multiple 4G and NB IoT engagements with global customers. And he's currently focused on the 5G GNB solution, end-to-end 5G system. So, so having said that, I'm going to let Ambarish take over. So
Thanks, Guna. I think thanks for the very nice introduction. Nivedita, can you please put forward the bio slides for the panel speakers, please?
Yeah.
Yeah, so I think we have had a couple of keynotes from Rajesh and Manish, which gave a lot of insight into the Open RAN ecosystem, and then insight into what primarily STL and Facebook have been focusing. So today we have a wonderful panel, like Guna said. I think we have a panel who has been through the telecom transition with decades of experience. I think we will have a wonderful discussion with them. So we have our first panelist, Chris Rice, who is the CEO of Access Solutions at STL. STL has been building solutions in the 5G radio, RIC, broadband access, software systems. So Chris comes with 25 years of experience. He's worked in the cloud-native SDN solutions for telecom companies. Prior to STL, Chris was with AT&T, focusing on building software-centric networks. Most importantly, he's got 90 patents and also the proud recipient of AT&T Distinguished Scientist Award. Thanks, Chris, for being on this panel. And as the next panelist, we have Brian Tan from Facebook. He's the director at Facebook Connectivity Ecosystem. Brian has been with Facebook Connectivity APAC for the past 5 years. He started the telecom infra project, rural access and shared fiber programs in the region. He's also responsible for developing new business and technical models with partners in the Asia Pacific region. He's in the telecommunications industry for over 20 plus years. I think it's wonderful to have Brian here representing Facebook. Thanks, Brian. The next speaker we have is Dr. Inder, who is the CEO of Iudx. I think he has been well known in the Indian telecom ecosystem and various Indian forums. The Iudx is an Indian urban data exchange program. Along with that, he's also the visiting professor at Indian Institute of Science, Bangalore. He's worked as a senior executive at companies like IBM, Ericsson, and AT&T. He's also been an entrepreneur. He has founded 2 venture-funded startup companies. He was the founding chairman of Open Daylight and an open source networking initiative for the Linux Foundation. I think we've seen a lot of his contribution in that areas. Dr. Gopal has had a distinguished research career in computer networks. He's had more than 20 patents and more than 70 technical publications to his credit. So he is also a fellow of the IEEE. Thank you, Inder. Thank you for joining this panel discussion. Hope to have a nice panel session with you. Next, we have Hank, who's over 40 years of experience in the telecommunications. He's focused on inception to deployment. I think nothing else is required to speak about Hank. Given this experience, he started career in Bell Labs, continued in leadership positions in various companies like Johnson, Bell South, AT&T. He has held various responsibilities in the network and architecture, technology standards, certification. So he's an industry expert in the ORAN space. He's currently a member of executive committee and alternate board representative in the ORAN Alliance. Thanks, Hank, for being on this panel. Hope to have a very good discussion in this panel. Can you please move to the next panel speaker? We have Gilad, who is the CEO of ASOX. Gilad co-founded ASOX in 2003. He's having extensive knowledge in mobile and telecommunications. He has over 25 years of hands-on experience in product management, sales, marketing. He's steered ASOX towards its focus towards the virtualization, primarily the cellular virtualization and mobile clouds. He has several patents in the areas of signal processing and communication. Thanks, Gilad, for joining this panel discussion. Can you please? Okay. So I think like what Manish and Rajesh spoke, we have seen that the 5G network capacity continues to increase multifold. There has been a lot of focus on bringing agility and speed to the telecom industry, ranging from development, testing, deployment. There are a lot of terms like zero touch, zero downtime, are becoming more of a necessity than of ease of operation. We saw that in the 4G space. Now, with the various open source projects like OpenDaylight, OpenNFV, OpenStack, CORD, and others have more innovation across the telecom components. Now, the last piece of the puzzle is being the radio access networks, which are in the edge, and then they allow physical access to the devices. So but they have the long history of having proprietary solutions for the hardware, from all the way to the application. So I think it makes that part, makes it very difficult to innovate in the same area. So I think in this session we'll focus primarily on to see how the open systems, primarily the Open RAN, is gonna evolve in the access part, and then what are the different challenges, and then if there are a lot of insight that the industry we can get from the industry experts on these areas. To start off with, I would like to ask Hank a question as to you're deeply involved with the ORAN with the ORAN standardization. From your experience, we would like to know what are the major challenges in defining the open interfaces for Open RAN architecture. So Hank, if you could share some insight into that, it'll be great to start with.
Sure, thanks, Amrish. I think the biggest challenge is that there is a lot that needs to be defined in Open RAN in these interfaces. After about 40 years of development of RAN systems, today's RAN networks have a hugely diverse range of customers and applications, and a astoundingly sophisticated set of capabilities are built into them. What we need to do is to define open interfaces between the RAN components that can support all of that. So that leaves us with a lot of work to do. And in order to tackle it, we've got to prioritize it and work it in stages. We're starting with the key areas, we're starting with the basic capabilities, and then we go on from there and expand in both the scope and the depth to keep moving forward. To help with this, ORAN created something called the MVP, which in our case stands for Minimum Viable Plan. This plan helps us organize and prioritize this vast quantity of work across the different interfaces and work groups, and it helps us produce releases that deliver capabilities that operators can take into deployment. And that's been proving very useful to tackle that large amount of work. Another way of addressing the big challenge and the amount of work is by taking advantage of other people's work. We're very happy to beg, borrow, and steal from other areas. So within ORAN, the key foundation is, of course, 3GPP. They've already defined a wide range of data models that are being used within the ORAN interfaces. Another example is the Small Cell Forum's FAPI family of interfaces. So instead of creating new specs for the MAC-PHY interface, ORAN has been working with the Small Cell Forum and has adopted their interface. Another simple example is in the acceleration abstraction layer, where ORAN is adopting DPDK as the basis for the forward error correction look-aside accelerator approach. And then, another reuse comes from the very origin of ORAN, the merger of the XRAN Foundation and the CRAN Alliance. The XRAN Foundation had already been working on the open front haul interface, and that gave ORAN a head start on that set of specifications. So, the reuse is great at doing this, but it doesn't work for the brand new areas like the E2 and A1 interfaces that control how the radio intelligent controllers talk to the RAN and work with the other RAN components. So for those interfaces, we had to start at an early stage and define many of the key concepts. Things like where and when should you use the policy-based control interface versus a command-based control interface? Should you define protocols or SDKs? Should you define one large service model or multiple smaller service models? Through all these kinds of issues, different companies and even different experts within a single company can have different views. So to have an effective open interface, we've got to bring together a cross-industry view, and that means using a consensus process. That can raise the work level because reaching consensus on a hotly debated technical topic can take a lot of time and energy, but it's well worth it because it reaches a better technical decision. And as a very beneficial side effect, consensus also brings buy-in across the industry as a whole. So in the long run, it saves a lot of time because that decision doesn't have to be revisited. So there's a large amount of work to do, but by chunking it up, borrowing from other places, taking it in phases, we're making good progress and meeting that challenge of getting all this work done.
Thanks, Hank. I think that was very useful. I think I like the part that when you said MVP and reuse, I think that are the quickest and the most efficient way to go about things. I think that is definitely a very nice perspective and view on how ORAN is approaching the entire standardization aspects. My next question is to Chris. Maybe Chris, if you could speak about some of those top 3 things that an operator should consider prior to migrating to open architecture. I am taking the liberty to ask this because you're from an operator background, so we would like to see what are those things that you would basically consider if you have to take ORAN to the.
Yeah, no, I think it's a good question. I mean, I think number one is that you want to make sure that what you're deploying will pass, muster in terms of what your expected KPIs are, what the expected performance is, and most importantly, what customer expectations are. And so you can't be deploying something that's seen as lesser for some reason for the sake of deploying openness. That won't work. And I think that was part of what Manish was getting at earlier in his keynote around developing the ecosystem associated with it, right? And so I think that's a key one. That's number one. But I think the other thing is once you have that, or once you believe in that, you got to also make sure that you have something that is truly open. In other words, if this becomes concentrated in one hand or two hands, and it's got an open sticker on it, but it's really kind of the same thing that rebranded that we're already seeing in the existing ecosystem, that it won't satisfy the need of what's expected in terms of delivery. And I'll just harken back to a lot of different things, but one of the ones that reminds me of this is that in the early days, in the late 80s, early 90s of compute, when there were all these specialized vertically stacked delivery systems associated with compute, and it kind of opened up. It took a while for it to open up. It took a while to develop that ecosystem. And I think some of those lessons are kind of being applied here. And I think that's part of what Facebook's trying to do as well. And I think the other thing is, and lastly, there should be some differentiation associated with it. And what I mean by that is that, like let's take the RIC. And you can think of the RIC, and other folks talked about it, I think Manish did and others, but think of the RIC as kind of the operating system for Open RAN 5G. I mean, it's that fundamental that, the applications will get built on top of it. And you can imagine applications there that don't exist today, and quite frankly, would be a big lift for carriers to go and deploy. And I'll give you an example. Like if you have 2 separate RANs that you want to go deploy something on today, like SON, that's a huge lift because you've got to do it for 2 separate vendors, 2 separate interfaces. You got to make sure that you keep up with 2 separate release schedules. It's the barrier to go put that in the network is higher because the business case is higher in terms of the effort that you have to put in to do it. And so if you can lower the cost to do that, you can imagine more and more and more of these deployments happening, and you can get into things like Manish was talking about, which is like the AI capabilities or automation capabilities, which will provide further enhancements. But that only happens if the ability to implement that in the network and that barrier is low. And things like the RIC are going to help that. And that's a differentiator. So those are the three big things that I'd say that, as a carrier or a telco that you look for when deploying this kind of technology, and why you might want to shift.
Thanks, Chris. I think that was very useful. I think it was a very nice insight into what the operator pain points are really. Further, next, since you were saying there's a lot of activity on the ecosystem, my next question is to Brian. I would like to see, I know Manish presented what the FBC's role and what are the different activities that they've been doing. Can you please also give us a little bit more insight on what are the major challenges that you've seen when you are actually getting in a lot of vendors into the ecosystem through FBC? So if you could please elaborate a little bit on that.
Sure. Thanks, Ambarish. And first of all, good evening to everyone. So the challenges we see as we disaggregate the network is that there needs to be some commonality of where the requirements for specific use case, so that you don't pull the ecosystem in 10 different directions. And so within TIP, as Manish explained, we define the use case requirements, map out what the industry-wide Open RAN roadmap and requirements for the MVP is. If I may play on Hang's word, this would be the minimum viable product, to find the right permutations that support the ORAN MVP. At the same time, we see that there's one of the obstacles is there's going to be a lot of integration and test and validation that needs to be done across all these components. So within TIP, we're considering how we can, again, consolidate these, do a centralized testing validation for specific blueprints, batch them, and so that there is a baseline which Chris and the rest can use to say, okay, we've done this within TIP. This is done 0 to 60, 65, 70%. And then specific to each service provider, there are specific requirements. You test the last 30%. So helping the industry scale the integration and test and validation are big obstacles that we need to overcome. Manish also mentioned from a perspective of Even Start program that there are 4 critical gaps. The first is the availability of radio units and DUs. Specifically for 4G, there are many bands that are out there. And so having the right band support for specific geographies is an obstacle that we need to cross. And we can do so by some intelligent hardware design, which I can touch on later. The other, of course, is interoperability. How can we work through the initial teething issues of interoperability and scale that faster? The third is massive MIMO. To truly unlock the value of Open RAN for 5G, the massive MIMO performance needs to be on par. I mean, Chris made a really good point, right? From a service provider perspective, the first criteria is that your KPI must be equivalent to what you already have or you expect. And so massive MIMO is a big area. It's a big technical challenge, requires close integration with the DU software. And that's something that we are working with the OEMs, both the massive MIMO OEMs and as well as the software OEMs to solve. Finally, from a power and performance envelope perspective, we believe that silicon has a role to play. And so how do you bring out the right silicon, have the software players be able to develop their platforms across not just one silicon, but multiple silicons. And that's a big challenge that the ecosystem needs to solve.
Thank you, Brian. I think those bits of information was really useful. I think it also echoes Chris's views. My next question would be to Gilad. I think there has been so much discussion about the topic of truly disaggregating the hardware and the software. So, I mean, ASOX is one of those pioneers in the CU and DU software. solutions. So I would like to ask you, what were the various challenges that you encountered when you actually went about disaggregating the hardware software? If you could give a little bit more insight into that, it'll be great.
Sure. I think for us, if you look at independent software vendors such as ASOCs, Open RAN actually opened up the door for companies to specialize. So we are today less involved, or I dare say even concerned about things that are happening on the radio side. So open radios, there are very good companies and there's a very strong ecosystem. And more we can actually take the availability and the openness of these radios for granted and focus on what we want to do, which is cloud-based software. So I think throughout this session, given the focus on telco, we have to bear in mind that what we are seeing in the markets that we are involved, which are more enterprise oriented, is that Open RAN really paved the way for 5G to be deployed as a software application, or in our case, a cloud application where we literally, as an enterprise, you can download our 5G network from a marketplace. So we got already to the point where the disaggregation of hardware and software is so pure, if you will, that some of our customers are not even aware of those technical challenges that you have mentioned, and frankly, I'm not sure I even remember all of them these days. So I think that perhaps that's a great testimony of the maturity of Open RAN and virtualization of RAN, that now companies like ASOC were pretty much taking for granted the underlying virtual operating systems, if you will, from the likes of VMware and other companies that have already hashed out a lot of the complexities. And frankly, we can actually not just focus on building the best 5G software, but spend a great deal of our time even going up the stack in terms of integrating AI and other complementary technologies to the mix. So yes, there were some challenges, and I'm assuming from what I'm hearing from my panel partners that there are some still quite interesting challenges to be solved on the macro level. You mentioned massive MIMO and others. On the enterprise level, in the private network sector, our challenges have to do today more with the adaptation of specific use cases, with figuring out the right business models for the deployments. And frankly, I dare say that the technical challenges that have to do with building 5G private networks are, probably a problem that was, more important to be discussed in 2019 and a better part of 2020. And this year, the real challenges have to do with market education and with training of system integrators who are now absorbing these technologies to create better products. Hank mentioned some of the interfaces that are making this industry possible. I can mention as an example also the O1 standard, which I think was a brilliant move moving forward. And now basically all these different SIs are coming to us and we just say, hey, there's an O1 Northband interface, just tap into it and get products up and running. So ORAN has been, while it was very focused on the telecom industry, maybe without even knowing, has actually opened up the door for making 5G really, really easy on the enterprise level.
Thank you, Gilad. I think I have a follow-up question for you, but I'll get back to you. Let us also give other speakers an opportunity. So I will get back to you with a follow-up question. I have a question on the enterprise connectivity part. My next question is to Dr. Inder. There has been a lot of healthy collaboration between the academy and the industry in India primarily so far, which is very positive. Given all the recent activities with respect to the Open RAN disaggregation and also open source, primarily because you've been very closely working on the open source ecosystem, what do you think needs to be done more in addition to what we are already doing with respect to open source and Open RAN disaggregation? Are there some areas that people need to focus, the ecosystem needs to focus, or is there additional stress that needs to be put on? If you could please give a little bit more detailed insight. In that we cannot hear you. I think you're on mute.
I'm sorry. You can hear me now, I assume. I think we can look at some adjacent spaces and try to, get some lessons from that, right? So, for example, if you look at, say, data center networking, right, which is an area that I used to work in, and in fact, I was responsible for IBM's networking business, which was predominantly focused on data center networking. If you look in 2011, right, which is kind of where I took a snapshot of the industry, about, I would say, 75% of market share measured by the number of ports deployed were a single vendor, right? I mean, basically proprietary systems and pretty much dominated by a single vendor, and that vendor begins with the letter C. And the whole notion of disaggregated, open networking, open source was pretty much unknown. You'd get laughed out if you kind of even proposed anything like that. And fast forward, actually something like 7 years, maybe 8 years at most. And I took a snapshot, I think, in 2018. You will see about 55% or 60% probably of the deployed ports in data center networks now are based upon open networking and disaggregated white box type solutions. So you've gone from zero to a pretty much majority dominant deployment of open solutions in a period of about 7 years. Right, and you had all the same squawking that took place, security issues, management, performance is not going to be good enough. You have integrated systems, closed box, proprietary systems, which are kind of optimized to work, have software, hardware work together. Things will work much better. All that didn't make any difference. The industry moved and completely transformed in about 7 years. And the telecom industry is a lot slower for all kinds of different reasons, and probably, should have gotten there by now. But I mean, sooner or later, I'm pretty sure it will get there. And I think that it's real important that within, for example, the Indian ecosystem, right? I mean, speaking from India, that we understand that there is a transformation coming. And that there is an opportunity. I mean, this is going to become, an industry where there'll be a whole bunch of new players. Many of the legacy players might not necessarily have the same dominant share that they have right now. And there's a real opportunity for Indian industry to play a major role, and particularly the software industry. And I think one of the previous speakers talked about, the enterprise market and the impact of 5G on the enterprise, and particularly, I assume part of that is things like private 5G deployments and so forth. I think there's huge software opportunities, whether these are generic kind of sort of applications that do things like manage the infrastructure, do edge optimization or network slice management or whatever it is that they do in a generic way, or whether they're industry vertical focused, right? Finance vertical, various kinds of verticals. Rural banking, for example, I think has a huge application. These are all things which I think Indian industry can play a key role in. And one of the things that we really hope to do going forward, working with academia, working with the government needs to play a role as well. There's, I think, a lot of effort to kind of have the government be a catalyst in some of these areas, working with smaller indigenous players, hopefully really to create a groundswell of players that can contribute, primarily in the software application space, I think, but maybe in other spaces as well.
Thanks, Itar. I think that those are some more insights into the academia's contribution to the entire Open RAN disaggregation. So my since there's a lot of focus that Inder was specifying with respect to software part. Now my next question would be to Brian. As part of your ecosystem management, you've been involved in specifying also the hardware. I think the other panel speakers did mention that even as part of the Open RAN or the ORAN, they also are trying to define a standard hardware. But there are also certain activity that Facebook is trying to do in terms of defining the hardware platforms. So what are the challenges that you're seeing right now in terms of coming up? I mean, when you're doing this exercise of defining the hardware platforms, if you could please share some more.
Sure. First of all, I think it's important for me to call out that we complement the work that Hank and the team does in the ORAN Alliance. We use the specifications and the interfaces that they define, and we try to find the permutations that create this minimum viable product that operators can deploy. Specifically, I think on hardware, on the Even Start program, we're helping define reference architectures that are also modular. I'll give an example on the RU. I alluded to the fact that on 4G, there are many bands, across the globe with different for different operators. And so what this modular architecture allows is for the radio front end to be rebanded quickly. So if you have a sub 1 gig band, it can go from band 5 to band 20 and all the sub 1 gig band, and you can also do band 3, band 1, and TDD bands pretty quickly. So that will address this modularity, will then address the proliferation of RU combos that is needed. But at the same time, the modular architecture then retains common components like FPGAs, so that the total volume of all RUs uses the same or similar type of FPGAs, and you can drive cost savings there. I think in the medium term on the DU, we think that there needs to be a diversity of hardware platforms anchored by different silicon to bring the right performance, cost, and energy efficiencies. So today, if you look at a software layer 2, layer 3 OEM, it is a significant effort to integrate the software onto a layer 1 platform and harden it. Typically takes 12 to 18 months. So it's a heavy lift, non-trivial. So the ecosystem needs to find a way to harden, optimize, and upgrade these solutions rapidly. So we think there's a two-step thing that could happen. One is critical to have standards in place to define interfaces between various components in a stack. First place to start could be to ensure that the silicon providers agree on the same software paradigm for a given hardware architecture. So in the case of the DU, we need standard interfaces for both look-aside and inline acceleration, and those interfaces can be agreed upon in the ORAN Alliance by the component suppliers. Now, once we have that baseline interface agreed, so this is not the 7.2 interface, right? The 7.2 interface is the one between the RU and the DU. This goes into the DU itself. So once we have the baseline interfaces agreed upon for possible hardware architectures, then it will be possible to develop the software frameworks to speed up and simplify system development. And one promising example is what is termed as RAN DSL. So RAN DSL stands for, DSL in this case stands for domain-specific language. So this is a space that promises an abstraction layer that will enable a diversity of hardware and silicon platforms to be brought into play in a very quick way. Ambarish?
Thanks, Brian. I think that is a good point that that something was running in my mind. You referred to the interfaces internal with respect to when you're defining a hardware or when there is a layer 1, layer 2 integration. I think that those are some of those areas that I think have been a little bit lagging. So I think that is something that we need to probably see how the industry is going to address it. Thanks for that. My next question is to Hank on the same lines. With respect to the interfaces, Are there any specific areas to focus in the near time in order to increase the pace of the standardization, so that then again, then the adoption of Open RAN also is basically is faster? It is again in the context that, since Brian was referring for interfaces internally, when people are using hardware platforms, having standard interfaces internally as well. So if you could at least highlight something on those areas, what are the specific areas that ORAN is looking at, ORAN needs to look at for that matter, to increase the rate of adoption?
Good, thanks. Yeah, so so ORAN is looking across a range of interfaces. We're basically taking, the RAN, and we decompose the architecture, and a lot of the work on the specifications is to specify that full set of interfaces between the different block components so you can mix and match them. We've been making a lot of progress across all the interfaces. Different ones are at different stages. If you go to the o-ran.org website, you can see some of that progress in the most recent blog post. We've just released a batch of 47 specifications, and some of them involve the open front haul specs. That's one of the more mature interfaces, and those specs are at version 7 right now. So we're well into the phase of expanding that and doing the deeper dives and getting that one fleshed out. O1 was also mentioned. That's a key interface, and it's been important enough that we moved the O1 work into its own work group now, work group 10. And the recent specs for the O1 interface are at version 5 and expanding to start to include things like lifecycle management. So, again, a lot of work and energy going into that, and that's one of the ones that's also making a lot of progress. Workgroup 6 is continuing its work on the O2 interface. This is the interface that controls the interaction between the RAN and the cloud, and it's how the virtual RAN components can ask for capabilities and services and horsepower from the cloud itself. It also defines the acceleration abstraction layer, which lets you kind of get to the specialized hardware components that can offload some of the highly processing intensive things that would be difficult to fully virtualize. But if you can make general accelerators available as part of the cloud infrastructure, it lets you operate more efficiently and more quickly for those specific areas. So the O2 interface specs to interact with the cloud are generally at version 1 or 2. It's early in the life cycle. And right now we've got new specs on cloud infrastructure, inventory, and lifecycle management that help enable cloud registration and discovery services that are aimed so if you can have one vendor's RAN components work on another vendor's cloud components. That acceleration abstraction layer, the AAL, has also been making progress. As a new type of interface, it's getting started by initially focusing on the forward error correction aspect instead of looking at the whole PHY. We kind of picked one example. Let's go after and get the specifications done for forward error correction. And even in that case, there are methods you can use. One's called look aside and the other is called inline. So we focused initially on the look aside view there. And in addition to that, we've kind of built that on top of the DPDK interface, as I said before. So Workgroup 6 has released a new version 1 spec that describes the requirements for this FEC AAL profiles. So, ultimately, all of these areas are going to be really important to building the RAN ecosystem. They're extending the scope and further opening the ecosystem for innovation. But, some of the recent plug fests and trials and deployments are showing operators don't have to wait for a full set of all of the ORAN specs covering all of the interfaces to get started with ORAN. Deployments and the benefits from those deployments can start with subsets of the interfaces and then build forward and extend from there.
Thanks, Hank. I think that clarifies and gives a little bit more insight into what are the areas that you're focusing internally with respect to the standardization of the interfaces. My next question is to Chris. I think something that gives an operator view basically. So we would like to see what are some of the migration strategies that the brownfield operators could use towards adopting Open RAN architecture while they continue to use their legacy infrastructure. Now, I think we also had some more details that Rajesh and Manish gave with respect to operators moving from legacy towards that one. So we would like to hear from you as to what strategies could be used further. Chris?
Yeah, sure. So I think number one, it really kind of hits the software area. So for instance, if there are people out there or folks out there who are looking to deploy SON or maybe upgrade their SON system, they should think about doing that more in the RIC vein. And what I mean by that is you can imagine that the RIC, Brian and others talked about and I think Manish talked about like the near real-time use cases associated with that. And you certainly need open interfaces to do that. But remember, there are a lot of valuable use cases that can be provided by the RIC in like a non-real-time case. And energy management's, one that applies almost universally to every operator. Everybody's interested in saving power, good, greening of the world, good for their pocketbook. It's a high OpEx area for them, but there are others as well, right? And there's automation around, addition of new cell sites and other things. And I think, looking at the RIC and looking at use cases for these kind of what I'll call non-real time is an example where brownfield operators could go deploy it, put it in place, they'd have a RIC in place, and then you can turn on the near real time features as you deploy the infrastructure that would be Open RAN. So I think that's a logical thing to go do. The other thing I'd say, and I don't want to minimize this, but I'm going to take a little bit of a contrarian view of this brownfield, greenfield, because everybody always brings this up. But, and I think Hank may support me in this, but, every time you go to a different G and you're an operator, it's almost like it's a greenfield. I mean, there's very little that gets left behind. There's a little bit more as time's gone on, but most of this is kind of rip and replace. And so, for instance, if you've got new spectrum or if you've got, different geographies or you have different venues, those are great places to go and put this technology in place. I think operators, again, still have to be convinced of all those three things that I mentioned earlier, right, in terms of readiness and KPIs and differentiation. But I think that's there. But I don't want to make too much of that. I don't want to minimize it either, but I don't want that just to be this thing that everybody can just kind of throw out greenfield, brownfield, and everyone throws up their hands like, oh, who knows what to do. I don't think it's that black and white. I think it's much more nuanced than that. I think operators have been through a lot of that before. Going back to Ender's point around, the time it might take operators to go do something versus data centers. I'll just, because I went through some of this, I led some of this, and I'll just, tell you that the big difference is, in a data center, there's essentially one customer. It's the person who runs the data center, and the feature set is very limited. In the service provider side, first of all, you like to sweat assets longer. Just that's the way the business model works out. But the other thing is you have customers, and you got to make sure you have all the feature parity for all the customers, and you got to make sure that it'll work within the operations team that you have, which is probably pretty diffuse as well. So I think there's reasons for that to happen. But going back to your original question, I think those are some of the reasons and some of the ways that people can go deploy it, because we heard, going back to what Ender said, we heard all those same things on the wireline side, and why you couldn't do this, you couldn't do that, why the data center wouldn't apply. And, and fundamentally they turned out not to be true. And what we did is we looked for very specific places where we could go do it and isolate it and make it work. And I think that same thing is true here in the RAN.
Yeah, thanks, Chris. I think I like the point that you mentioned that the G's is primarily a replacement, as primarily you rip off the entire thing and then move on. So I would like to get Gilad on to answer my next question, because he's the one who is going to rip apart the G and move to the next G. So, Gilad, say you mentioned you are into private enterprise connectivity. You're seeing that there is a major deployment use cases there. So how do you see ASOCs addressing that? Are you really ripping apart the 4G and putting the 5G, or what is the approach that ASOCs is gone about that?
Well, it's of course very specific to industries, but in the main market focus for us in the industrial use case, we were actually quite surprised to see that wireless usage was incredibly small. So perhaps we were reading too much of our own industry newsletters, but LTE or even Wi-Fi, which are typically mentioned, were not really that integrated into the industrial world, at least the one that we see. So in many respects, you could argue that the industrial shop floor is more of a green field than something which is evolutionary. That said, for our customers, and again, I think that's quite different from telcos, the choice of technology for wireless is a second priority question. That means very few factories would come to us or even to our SIs and say, hey, we want a 5G network that does 1, 2, 3, and 4. Most of these customers, if they understand at all the subtle difference between different wireless systems, are more concerned about, hey, how do I make my robot move through the production floor seamlessly without disconnect? So how do I get the right video feeds to work in a reliable way? And then, so it's really more about the end case. And then naturally, after that end case is defined, you got to make sure that the network is the one that is reliable enough and optimized enough and secured enough to support it. So as much as we would want to say that 5G is the driver for the industrial use case, it's actually not true. The drivers in the industrial use case are better and need to handle information, to handle video, to handle mobility. And 5G is pretty much comes at the second step to augment these kinds of technologies. Something that is worth thinking about from telco perspective. And I think in that respect, we're not addressing RFPs. We're seldom addressing specific SLAs or SLAs in the way the telco is used to address. It's more about the services. It's services first, infrastructure later, while in the telco world is build it and then they would come. And that's kind of the big divide that these two industries make. Maybe one last observation is that no less important than the 5G performance is for enterprise is making sure that they can deploy it and they can maintain it and they can leverage it on their own. So having the sense of control, very few enterprises will know what a CU, a DU, or a RIC controller, or even an open radio unit are, but they do understand capacity, they understand service chaining or service slicing, perhaps not in the 3GPP manner, but in the way that they can understand. So they do understand the utilities of 5G, but they're less interested in perhaps some of the topics that we addressed today. So our job really as mediators is to translate not just the acronyms and the topology of ORAN and vRAN into the enterprise world, but also to make it easy for them to deploy it and to control it as they control storage or any other IT service they have.
Yeah. Thanks, Gilad. I think that was a totally different perspective. I'm assuming you would have got all this hands-on feel when you interacted with some of your customers, and then I think that really gives a different perspective to look at as offering 5G as a service rather than just a standalone product. Thanks for those clarifications. So my next question, Inder, I know we are running out of time, but then one last question to Inder. I think there's a lot of talk about open source being used in the telco system. So can you just speak to the topic of how it can meet the carrier grade performance, especially in a virtualized open RAN platforms? If you could please give your perspective on that. Inder, I think again you're on mute, please.
I'm sorry, I apologize. I think just as you saw in the data center, right? I mean, I keep coming back to that, and I'm sorry to keep using this analogy, but just as you saw in the data center, I think you will see similar open source initiatives, which will kind of become mature and become production quality, and probably already are in many cases. And whether it's on the RAN, specifically on the RAN side, things like open air interface and so forth, which I think have reached a certain level of maturity, or whether it is on the maybe on the 5G, on the transport side, maybe the 5G core or the 5G transport, or whether it is on the application side, the RIC and components associated with that. I mean, I think you will see open source. I mean, I think it's already happening. I think it'll reach a certain level of maturity, and you see initiatives around the world, including hopefully in India as well soon, where people are starting to assemble a lot of disparate open source pieces. I mean, the real problem in open source, I think, and certainly it's true in networking, is what I call the Tower of Babel effect, right? Which is there's just so much open source and so many kind of disparate, random projects, and some of them, very well run, some of them very poorly run, that it's very hard for somebody, say a carrier, to kind of go and, actually deploy, and something out of open source, because, the level of integration, testing, the level of even just curation of the components, selection of the components. I mean, it's hard to do. Do you go with Linux Foundation, ONF, whatever other, group that happens, industry group, there's just so many of them. So I think there's a significant amount of work to do in curation, in assembly, in integration, in testing, and providing an end-to-end system. And I can see several projects around the world, including hopefully in India, which are going down that direction. So I see open source very much as a key part of this, and I think it'll just as you see in other sectors, you'll see commercial, production quality systems deployed with open source over the next several years.
Thank you, Inder. I think we hope to see innovation coming towards as part of the open source contribution as well. I think
just one thing. I mean, you use the word innovation. I don't necessarily think you will see innovation in open source. At least that may not be the primary place where you see innovation. I think open source plays a key role where, it isn't necessarily the innovative leading edge, but what it is taking something that pretty much every vendor has to do, right? And rather than having every vendor go and build, a lot of the plumbing and infrastructure, have that infrastructure be open source. So, Linux, those are the kinds of things which I see as being open source, not necessarily where the bleeding edge innovation comes. That could still be, proprietary, and probably will be for a long time.
Yes. Thank you for those insights. And I think we have come to the end of the panel discussion session. I think we have crossed the time limit. I think we had excellent perspectives from all the panel speakers, from Hank starting off to give a detailed view on how ORAN is going about defining an MVP and reusing all the standards that 3GPP and other standardization organizations are doing towards Facebook defining the challenges in defining the hardware platforms. What are the other challenges? And then we have Gilad, who is given a very good view of the private enterprise connectivity. And then we have Chris, who is given a crisp view from an operator perspective, though he's not in the operator side now. I think he has a pretty good background. So he at least highlighted what are the key important aspects that people need to focus. Then we have Inder giving a little bit tangential, giving a different perspective from an open source view as to how it is going to contribute and help. I think the discussion was really wonderful. We have a different views from all the panel members. So I think we are open for questions right now. So I think if we can have all the panel members on the screen, we could wait for the questions. If audience, if you can, at least if you are if you have any questions, if you could please post on the Q&A tab, we could answer. I think we already have a couple of questions. We have a question for Gilad. Gilad, so the question to you was, if not Industry 2.0, where would we see the ask for private 5G? If you could please.
Sorry, could you repeat it? I'm not sure I got it.
So if not for Industry 2.0, where would you see the need for 5G, private 5G deployments?
Well, I think that every industry has its own Industry 4.0 phenomena. And the clues or the commonalities that I would look for is mapping of the IoT world into the digital world. I know it sounds very broad, but this commonality is actually very important, because if 5G networks are to provide value for enterprises, it needs to improve their information quality, right? So over the original SCADA in the Industry 4.0, but in any other, it needs to present better business opportunities. So any industry that has lack of visibility or ability to analyze information which is generated from machines, and I always give that example, information from humans is frankly not that valuable as people think. You know, people complain about $100 a year storage of all their memories on Dropbox, but the value of a machine operating, or the value of a video surveillance camera from a perspective of information can be incredible. So the commonality, what drives other enterprises is anywhere that you have to connect video, as an example, to AI, that's where 5G would come in. And those use cases are very broad and cross industries.
Thanks, Gilad, for clarifying that question. We have another question from Dibankar Das. For RU-DU interface, what are the hardware communication interface specified by ORAN? Is there a rep for generic hardware defined for RU and DU necessity? All those interfaces to be supported. I think I'm not sure if I get the question.
I think I can address a little bit of that one. Yeah, so if you look between the RU and DU, the main physical interface is one that's very well known and widely used in the industry. It's eCPRI. It's the Ethernet interface. So that's the primary 7.2 option interface between the RU and DU, and that's the key interface. Now Workgroup 7 has looked at other potential splits that some other companies may be interested in. So in some cases for small cells and certain types of picocell or small cell configurations, there's a desire to have potentially an option 8 or an option 6. And so there are reference designs that are there for that, but the main protocol focus is around the option 7.2x using that Ethernet CPRI. What the ORAN open front haul specifications bring into that hasn't been there before is the detailed message structure, how an ODU manages an ORU when those are from different vendors, how you manage MIMO, power control, initialization, data structures, the O1 interface, it goes beyond just the user plane. It adds in the control plane and even adds in the management plane. But the physical interface is pretty well known and understood and pretty basic. We haven't had to invent anything there. It's been these other areas in the higher layers where most of the added work has come in to enable multi-vendor interoperability between an RU and a DU.
Thank you, Hank. I think you answered the question. So while there are other questions posted, I think I have another question for Chris, maybe. Chris, I think there's been a lot of talk about the total cost of ownership. So, how do you think the TCO would be justified for the 5G Open RAN deployments from an operator view? Do you think it is going to be a benefit, or what is their view in terms of the TCO for 5G deployments? If you could brief.
Yeah, well, I do think there has to be a benefit. I mean, there is a reason that we went down this path. It wasn't just for the sake of just aggregating interfaces or anything like that. So they're going to need to see a benefit. But I will say, I don't think the benefit has to be solely in CapEx. In fact, I think that's a mistake if that's the way it's viewed, because TCO for an operator is made up of CapEx and OpEx. So, capital expense and operational expense. Capital expense is typically only 20 or 25% of the total cost of ownership. The other almost 80% is OpEx. And so, for instance, I'll tell you in STL, our goals are, very specific around, smaller size, lower cost, lower power, better deployability, better operability. We look across all 5 of those dimensions, and, those really hit the operational expense, because there's a 3-to-1 or 4-to-1 lever there compared to the CapEx. And so I definitely think there has to be some benefit, but that can really come even primarily in the operational expense. And I think that's where like the RIC and kind of the X apps and R apps really come in, because if that's an open platform, you can get best in class people to do that. The barrier to do it smaller, so you can really drop that operational expense, which makes up again about 3 to 4 times what CapEx would be.
Thank you, Chris. I think that clarifies my question. Further, I think we do not have any more questions from any of the audience. So I think Guna, should we maybe we can wind up the panel session. I would like to thank all the panel, Hank, Chris, Gilad, Brian, and Inder for being present, and some of them being present at the very early morning in the day. And thanks for your participation, and it was really an exciting session, and wish we had more time to continue and discuss some of those detailed aspects. But thank you very much for being here. And over to Guna next.
Thank you, Amrish. I mean, that was definitely a great panel set discussion. I mean, I wish we had more time. I mean, it's incredible to get all of you guys in a single room and talk about all these issues. I think it's so interesting that we could keep talking about this forever. I think there's plenty of things to talk about, but unfortunately we ran out of time. So thank you. I think we'll probably wrap it up. And before that, I want to just mention a few names. Thanks for everyone. So thanks, first of all, Rajesh, Ambarish, for helping us put together the session. Thank you very much. Nivedita, thanks for being the convener. And of course, the keynote session, Manish, I'm not sure he's still around. Big thank you for getting up early in the morning and participating and giving us a great keynote and answering those questions. And of course, the panel. I mean, what an incredible panel, guys. Thank you. And Hank, it was, I mean, the amount of depth you were able to go into is amazing. And I mean, we all know how standardization can be a pretty arduous task, and thank you, and thanks for all the effort that you're putting behind the scenes that we're able to do all of this, right? So appreciate it, and Chris, great perspective. Appreciate all the insights. I mean, you're able to put your operator hat on and tell us about everything that's going on there. And Brian, thank you very much for the insight into the ecosystem. I mean, I think you guys are doing a tremendous job getting everybody together. I think without that, it's not going to work, right? And Inder, I mean, incredible job. I mean, you being your perspective on open source was very nice, and what you're trying to do and all your efforts in putting together a task force in India and working towards this objective, getting academia, bridging the gap between academia and industry, since you come with both the perspectives, is invaluable. And I'm sure all of us enjoyed listening to your perspective. And Gilad, appreciate your perspective on from a software stack perspective about how to, from a deployment perspective in Open RAN. It was very insightful. Thank you, and good luck to all the deployments. I think I got everyone. So thank you guys, and of course a big thank you to STL for sponsoring the session. Rajesh, thank you for the great keynote and being a co-chair for us. So for everyone around the world, thank you, and we can wrap up the session now. Appreciate it. Appreciate all the time. Thank you.
Thank you.
Thank you.
Thanks.
Thank you. Bye.
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 And thank you, audience.